am a senior lecturer at Lancaster University, the engineering department. My research area is chemical engineering as a broad, but particularly I am interested in reaction engineering applications to a sustainable technology, including green processing, process intensification, bioconversions into valuable liquids, fuels and energy overall. The company we are working with is ICT Reverse. It's a company based in Lancaster, and they are involved in the reverse technology and reverse logistics and the recycling e-waste or electrical waste into valuable materials. Particularly they are looking, or they are processing different types of electrical waste, wiping the data associated with them, and then seeing different options to be taken forward.
ICT Reverse is one of the UK's leading IT and communications asset management companies. We deal with large blue chip companies, FTSE 250 companies, sort of third industry and public bodies, and take away their old IT and comms equipment when they're finished using it. We data erase it, provide them with the correct paperwork for the regulatory body, whether that be the Environment Agency with a waste transfer note, hazardous waste consignment note, an erasure certificate for their data compliance under GDPR. And then once that's done, looking at the age of the devices we've treated for them, they'll either end up with an invoice for the services we provided them or a rebate for the assets once we've remarketed them. Because of what we do, we take e-waste off the market under the WE directive anyway, so we have a positive impact on the environment. But what we want to do is, rather than what we have as a consequence of our core business, we'd like to actively grow in terms of our sustainability and look at what we could do above and beyond. We are currently actually applying for our B Corp qualification under sustainability. In terms of economic growth, obviously we'd like to perform year on year and increase our market share within the ITAD industry. So we've currently got 2 KTPs going, your traditional KTP and an accelerated one. Both are really dealing with our waste. So whilst we treat other people's waste here in terms of their e-waste, we still do generate our own waste. And what we're trying to do is treat that using these KTPs. So we have the standard KTPs focusing on bioleaching. Bioleaching is using bacteria to try and break down e-waste to recover the valuable elements, copper, gold. The issue with that is the technology's been around for a while, but the scalability to bring it on a commercial level isn't there. So we're currently working with the university on a KTP to do that. And the second one is around reusing our plastics. We generate a lot of plastic waste from the IT and comms that we treat. And what we're looking to do is be more sensible with that. We're trying to create a closed loop that we're trying to recycle our plastic, so our ABS plastic predominantly, granulate it, create a 3D printed filament, print parts that we can then use in repairing other assets. So we're currently looking at server caddies, hard drive caddies, printing them from our recycled plastics. So essentially both KTPs are focusing on sustainable and green ways of using the waste that we generate as a consequence of our business operations.
So the KTP project came from an idea from the company, where they are generally or fundamentally working on data sets, okay? And at the same time, they do also reverse technology, in a sense they try to, or they do repairing or recycling and repairing electrical materials and then send them back to the market. However, ICT Reverse is also ambitious, along with the data sets and the recycled material. They would like now to look at options to take advantage of valuables or metal valuables which are in the e-wastes.
ICT Reverse had this waste problem and we were aware of it, but we knew that we didn't have the tech expertise or the resource or the time or the person in place to help us achieve getting the problem to a solution. This is where the relationship with Lancaster University comes in. They have the tech expertise, they have some sort of setup up there, and they have these people that have this knowledge. So engaging them through a KTP meant that we could work together to try and achieve our desired solution in a much faster and efficient timescale.
ICT had the idea, so they were really good in this regard. They knew what they wanted. They wanted to look at some way of solving this nothing to landfill issue while still reclaiming value from something that was thrown away. And what was really quite nice was that they were able to recognise the problem, and I was able to come in and apply the skill set that I had at furthering their way to achieving it. So, don't want to describe myself as a tool, but I had the skill set but nowhere quite to accomplish or where to apply myself, and they gave me the direction, and then with them I've been able to help them refine what they want to be doing, how they want to be doing it, while learning up and picking up new trades to further all of us towards what I hope is a better direction.
The technology, to some extent, is not novel. It's not novel because the bioleaching processing is a technology that has been used for ore processing, but so far it has been rarely used at large scale for what is called urban mining. And the reason for this is because the metals or the valuable metals there in it are not highly concentrated. So there is issues so far about the viability economically speaking, and this is all about this project, is to design a bioleaching system that is scalable and economically viable. And we are lucky to work with ICT Reverse, which is a company that is also hoping to move forward with this project and looking at different steps and obstacles, see how we can reach some valuable technology first to be used by them and see options to be spread out. We are looking particularly to the PCBs, printed circuit boards, which constitute mainly about 5 to 10%, I would say, for any electrical waste or electrical material, and trying to find valuable materials there, generally metals. We do in some way also other materials, okay, plastics, but for this project we are working particularly with the metals.
So I'm looking at extracting metals from PCBs, so it's a massively undervalued component that we naturally see in the waste and recycling today, that quite a lot of these rare earth metals or even precious metals themselves are actually of a higher concentration in PCBs than they are in natural ores. So it's a massive source of potential value that we're yet to actually manage to extract or capitalise on. So I'm looking at taking them out of PCBs in a bio-friendly, natural way.
What we're looking to do here is integrate this and invest in this in the future. It's the scalability that's the problem here. Whilst it does work on a desktop and at a small scale, and we can recover the copper using electrowinning or electrolysis more simply, what we're trying to do is ensure that we can do that for the volume of waste that we need to treat, and that's how we're going to integrate that into our business. We need to ensure that once the KTP is complete, that we retain the knowledge and that we invest in infrastructure, products, services, tech expertise to ensure that we could take this to a realistic conclusion, not that we've just created a KTP, moved to a common goal and then not taken it to a commercial offering. On a personal level, it's quite an enjoyable process because you've worked with the associates and academics within the KTPs who will sort of further your understanding of what they're trying to do, and it allows you to bridge that gap between an academic understanding and what sometimes is a very layman or corporate understanding of where you're trying to get to, and it allows you to almost translate what can be sometimes difficult to understand processes to people internally in your business by spending time with the associates and academics through the process. So it can be, if you're willing to let it, quite an enjoyable process.
The KTP is an option for the academics to sense real world problems, okay? And so along with what often academics do, it means they try to understand, I would say, physical events, okay, for a project. For example, for this one, if I be just shortly here, it's about a bioleaching process in a reactor. It's a two-stage process where we have the first stage where there is a redox, okay, and using the biomaterial to reduce the ferric, which is the source, to then to solubilize the metal of interest, in the PCBs. So this is academic side. There are a number of challenges associated with it. Challenges with the mass transfer, because the process is relatively slow. The challenges with the toxicity that may be potential for the bioorganism that is associated with. But from the company side now, the company side is the side where this is when it reaches these steps, is how can the company want to make it at a wider scale. Okay, the company look at the scale. It needs to be achievable and scalable and successful. So this is what we are doing over the 2 years. So we started with very small scale, making it bigger and then bigger. And every time, gradually, we are looking at the challenges. Every time we scale up, we see challenges that we have not seen them at small scale. And this pathway of trial and error, in one sense, is making step forward.
So this is sort of like groundbreaking research in the fact that it's something that the company wouldn't be able to achieve without us, but because of them, we get the opportunity to look into it. We get the idea that we can change things around, the parameters we can look at, and actually know what we need to be measuring, how we're measuring it. Without the company, we wouldn't have an idea of where we're going, and hopefully that we were able to actually make them do this. Without us, they wouldn't have been achieved.